testing and debugging. This is a very important part of our software engineering. So today we are going to look at testing and debugging. We'll start with unit testing, and we know that during unit testing, the individual modules are tested in isolation, distinctively or separately they are tested. So if all modules were to be tested together, then it will be very difficult to determine which module actually has the error. And if we have some sort of coupling, then the error propagation also cannot be easily found out. So unit testing, it reduces debugging effort several folds. Testing is to test to identify the error, and debugging is to remove those error which has been the output of the testing phase. So debugging is done, the name says debug. So bug we can regard as the problems or the effects of testing, the after results of testing, and debug means D or removing the bugs. So if we do unit testing, it will reduce our effort of debugging. And once a programmer completes its module, then he tends to, or he should perform unit testing on this module which he has completed immediately. Then comes the next phase, next part, not phase of path. That once we have tested all the modules of the system individually, and we regard them as being unit tested, these modules are then integrated, combined in steps, not completely. They are not integrated, all the modules are not integrated at once, but they are integrated in steps, and it must have some integration plan. And these partially integrated system means one after the other modules are added, and then this partially integration setup is performed at each integration step. Then comes the system testing part. So what system testing does is to validate. There is a difference between verification and validation. Validating a fully developed system against the requirements. Validating is against the requirement, and verifying is what you are doing is correct. And validating means what you have done is correct, means it should refer to the requirements what actually you have made. So integration testing, as I earlier indicated in previous discussions, that we always follow an integration plan. And what is this integration plan? We develop the integration plan by observing the structure chart which was prepared before the design. So we can have a big bang approach, a top-down approach, or a bottom-up approach, or a mixed approach. This is how it is being made. We have already seen that this is example structure design of our example we have been discussing, that there will be a root, then validate number, then root mean values we compute, whether it is a good data, whether it is a computing of solution or displaying of solution, then we can get data, validate data. So this is an example structure design. And as we talked about various approaches, this is big bang approach, and this is the simplest integration testing approach. How it is done? All the modules are simply which shouldn't be there, but we combine all the modules at once. They are put together at once, and then they are tested. They are combined at once. So for small system, this approach can be taken, and this approach is good for small systems where there are only few modules. But as I suggested that we don't do it, so there will be some problem. And what were the problem? That if an error is found, then the localization of error, or finding where the error is, the point of error, is very difficult. And once they are integrated, we are not aware, or we cannot find that which module exactly, or potentially from which modules this error might have been generated. And debugging errors which are found during this big bang integration testing are quite expensive to fix. It will take a lot of effort, person months, to actually fix it. Then we have bottom-up integration testing. So we integrate and test the bottom level module first. So we have modules, we call them as managerial modules, and then we have modules in the lower level, and these are the basic interaction, input, output, system level modules. So we integrate and test the bottom level first. But the advantage of or disadvantage of bottom-up testing may be that when the system is made up of a large number of small subsystems, means a system has various subsystems, then This extreme case correspond to the Big Bang approach, right? When we have large number of subsystems, then we can really be in trouble if we apply this. And if we follow top-down integration testing, it starts with the main routine, means the managerial level module, means the root level module, and then these the one or two subroutine system in the system, they are combined. So we integrate like this, and after this top level skeleton has been tested, then the immediate subordinate modules, which are coming from the above main modules or managerial modules, these are combined again, and then they are tested. So this is combined with this is combined with this, tested, and this whole will be combined with these two and these two, and then again tested. Then we have a mixed or sandwich integration testing, and this would use top down and bottom up testing approach, and this is the most common approach for testing. Means we start from top also and below also. Why we do this? Because you know that certain subsystem or certain sub modules are very important for you, whether they may be on the top or they may be on the level which is a hierarchy below the structure chart. So what we do is we choose those modules which are very vital for us. We try to combine them, we try to test them first, and then we go on. So in the integration testing, for top down approach, we have to wait till all the top level modules are coded and unit tested, because top down approach would emphasize on testing the top level modules first. So the modules should be ready. We'll wait for those which are not been coded yet. And in bottom up approach, testing can start only after these bottom level or the low level hierarchy modules, they are ready. So these two approach require these things to be done. And when we talk about system testing, which is the validation with reference to the requirements, there are three main kinds of system testing. First is alpha, second is beta, and third is your acceptance testing. Alpha, beta, and acceptance testing. These are the three categories of system testing. So what is exactly alpha testing? The system testing is carried out by the test team within the organization, developing organization. So the test team would be from the organization only which has developed the software. And beta testing, we have or we identify certain group of friendly customers, those customers which are friendly to us, and system testing is performed by these groups of friendly customers. Not in this group will not involve any person from which is testing from the organization who has actually made the software. Acceptance testing is performed by the customer himself. Let me tell you this beta testing also, that alpha testing is done by the organization itself, beta testing is done by the friendly customers, and system testing is done by the customer for whom the software has been made, by customer himself. And then acceptance means the name it suggests that this testing is performed either to accept or to reject the system. Then comes the stress testing, which is also known as endurance testing. So if you are being asked about what is the difference between stress and endurance, they are the same. So we impose or we put abnormal, immense amount of stress to the capability of software. Like this stress can be in the form of data volume, can be input data rate, processing time, memory utilization, memory, and these are tested beyond the design capacity, and we would want this software to break down at some time. So how many errors are still remaining, how you are going to know that? We seed the code with some known errors, means we inject some errors which are known. So these are called artificial errors, and they are introduced in the program, and then we try to find out that and we test it. We test these seeded errors or injected errors and check how many of these injected errors are detected during testing. So this error seeding, let us say that n be the total number of errors in the system, and small n are these errors be found by testing. S is the total number of seeded errors, and small s is the seeded errors to be found during testing. So this is error seeding, n by capital N, s by capital S. These are in an equal ratio. So capital N, that was actually our total number of errors in the system, will be like this, and the remaining error would be simply n minus n, that will be n into s minus s by s. So these are the found errors, these are seeded errors, these are found seeded errors. This is how we can compute. For instance, 100 errors were introduced, 90 of these errors were found during testing, and 50 other errors were also found. So remaining error would be this 50 into 100 minus 90 by 90, that will be the remaining errors are 6. This is a good way of finding it. So error seeding, this kind of seeded errors, it should match, not, you cannot just haphazardly include errors. These errors should be as close to the existing error, but this is very difficult to predict this type of error, So what could be the categories of remaining errors which are not yet been surfaced? So this can easily be estimated by analyzing the historical data from similar project. If the similar project or this kind of project has already been carried out, and the testing report of that error can actually show you that what kind of errors can be the remaining errors. So what we have done today is that exhaustive testing of almost any non-trivial system is quite impractical. We need to design an optimal test suite, and test suite that we call as test cases also, that would expose as many errors as possible. So if we select test cases randomly, then many of the test cases may not add to the significance of the test suite. So it has to be very carefully designed pertaining to the software you are developing. There are two approaches to testing. These are black box and white box testing. So black box testing is also known as the functional testing. Functional testing means you only test the functionality of the system with input and output. And how to design this black box test cases? We require only the understanding of SRS document. So we don't require, or it is not expected for you to know design and code. While designing white box testing will require the knowledge of design and code. So this black box test, this case design, there are two strategies, main strategies: equivalence partitioning, boundary value analysis, and then this integration and system testing also we have seen. So this is debugging and testing part for you, and we'll be taking up more. Thank you so much. Take care.